Hi, good morning. I'm Mike Rime with the Office of Nuclear Energy. I'm here to present the Material Protection, Accounting, and Control Technologies call for proposals. So this past year, NE4 and NE reorged. Our office is now the Office of Materials and Chemical Technologies, and one of the subgroups under that area is the MPACT campaign. So looking at the fuel cycle in general, our areas fall under material recovery, fast reactor recycle, and waste form development. But I want to highlight the two lines at the bottom of this slide. Specifically, MPACT is focused on safeguards and security by design. And I'll talk a little bit more about that on the next couple slides. But additionally, MPACT can have benefits for process monitoring in nuclear facilities more generally. So our mission is to develop innovative technologies and tools to enable next generation nuclear materials management. So really, the focus is for new fuel cycles and new fuel cycle facilities. However, as I mentioned, our research can also be applicable to existing facilities, existing safeguards that are used internationally, and process monitoring for current facilities. So specifically, our objective is to develop and demonstrate advanced material control technologies that would fill important gaps, things we don't yet understand, and we need to figure out if the U.S. is really going to move towards advanced fuel cycles. Similarly, there are suites of analysis tools that are needed to assess effectiveness and efficiency and guide R&D to support these capabilities. We're looking to perform technical assessments in support of these concepts. And as I mentioned, a real key here is leadership. If the U.S. government and if any are going to lead and push for advanced fuel cycles, you need to know how to monitor and safeguard those fuel cycles. So this is my main slide, and the call this year is really focused on methods and approaches for integrating advanced process monitoring to enhance nuclear material control and accounting. And specifically, our focus is less on, we only have one proposal, one call this year, but we're really focused on integrative proposals more so than specific detector technologies. So in the past year, we funded some specific physical detector research, but this year we're looking for more integrative proposals that would tie together other things we've been working on. So in the previous talk, Patricia did an outstanding job talking about the fact that this work has been going on for a while, and if you're new to it, there's a lot to catch up on. Well, in this area, I mean, we've been working on detector technologies and tools for quite some time, and really we want to focus this year on partnering with universities in order to integrate some of these functions and to really start to understand the uncertainty associated between them. So more specifically, I suppose, bullet 2 on this slide, we're looking to integrate radiation-based and non-radiation-based data with the goal of providing quantitative analysis and error propagation to supplement traditional ways of controlling and accounting materials. And again, the overall goal, is to create a system that would meet NRC requirements for material control and accountability. So we have a 2020 milestone related to this call, which is to demonstrate a virtual test bed for these technologies. And though some of the writing is a little bit small in this diagram, I wanted to point out the fact that this is an integrated suite of capabilities. It's things on the far left. It's specific technologies that have been used for quite some time in nuclear technology. like voltammetry, you know, microcal, things like that. But it's also, you know, it's also a series of models, whether it's the physical facility model or, you know, safeguards and security models that have been developed over the years. So when you start getting down into the details, it gets, you know, it's fairly complex with the interaction between all of these tangible, you know, technologies and monitoring tools and the process modeling, and the models themselves that are being applied. So again, really our focus is to look to partner with universities to tie some of these things together. So in order to do that, it's really important that you partner with existing researchers, existing national lab partners. And on the final side, we have full contact information in order to help you do this. But I just want to emphasize the fact that you know, this program has done an exceptional job with working with national labs together with universities, but more specifically, you know, even having national labs use summer interns and postdocs and partnering them with the university, you know, professors and students. We have a really good working relationship, and we want to continue that in the future. So we want to encourage you to submit proposals and to ask questions, and I'll do my best to answer what I can here. But I also may get some help, and we also might have to follow up with you. So thank you very much for listening, and now it's time for questions.
Okay, let's see. First question. Are you primarily interested in development and demonstration in a simulation environment? Is there interest in demonstration in a relevant lab scale experimental system?
I would say both are possible. Our ultimate goal is to have a lab scale demonstration that is mixed with modeling. But as far as these proposals are concerned, we are open to either of those.
Is there a focus on aqueous or electrochemical reprocessing facilities?
Our focus is electrochemical. Okay, so I'm also, yeah, we would also be open to aqueous.
Attendees, if you have any questions, be sure to enter them into the question box in the GoToWebinar field. Okay, next question. Is the virtual facility testbed a computational modeling and simulation effort?
I'm not entirely sure about that. What I do know is, and I may ask for help in 1 second, but I will say that it is not a completely integrated system in the sense that everything you enter data and click a button and it outputs a number. It's really more of a patchwork of different models that work together. So they're intended to be modular. They're not 100% integrated. But I don't know if that really gets at the question. Could you please read the question one more time?
Is the virtual facility testbed a computational modeling and simulation effort?
You have to integrate what we have done with the different detectors plus different models. It's really an integration effort. But tell the people who can come back to their questions with my
Patricia, do you want to repeat that on the microphone here?
Okay. I will say for the 2020 we have a milestone, and we are trying, like Mike said, to integrate all the different detectors that have been pursued with also the part of the modeling and simulation. So I think it's an integration of both worlds. But we will come back to you. Mark Miller is the point of contact, the technical director, the national technical director of the campaign. So I'm not sure he's on the call, but if you want to leave your email, I guess we have an email, we can come back to you more specifically with the right answers.
Thank you.
Okay, next question. $800,000 over 3 years might be less when talking about a lab scale model. Is there a scope for allocating more funds?
I think we're limited, unfortunately, on the funding.
Okay, we'll stay on the line for a couple more minutes, see if any more questions come in.
As a reminder for all participants this morning, all of these presentations will be posted on nup.gov along with a transcript of the question and answer here. Any questions that aren't answered or need to be answered in more detail will be posted on that question and answer on nup.gov. That's typically within 2 weeks of the conclusion of this webinar.
Yeah, I guess I would like to repeat though, if I'd like to encourage people to email me if we didn't fully answer your question, and I will find an answer for you, or we'll find the right lab to partner with.